Let us take another example. NiCO taken 4 times. Continuation. BBT, NiCO taken 4 times. What is oxidation state of nickel? Ketura? What is nickel oxidation state? Pragnika. Zero. Metal carbonyl. Zero. So, nickel electronic configuration is argon 4s2 3d8. Nickel 0 means, is there any need to remove the electrons here? No need to remove the electrons. So, no need to write any oxidation state over nickel. What is the next step? Next step, swapping. Next step, swap these two, 3d8, and give some space here to write the orbitals. One, 2, 3, 4, 5, 6, 7, 8. Okay. According to Hawgo principle, we fill the electrons. Hawgo-Hall's rule. And 4s2, not the 4s2. Online students. Right? You tell me how many ligands are present here? 4 ligands. No. Number. 4 ligands are present. Right? So how many vacant rooms we have to create? 4 vacant rooms we have to create. Actually, nickel is a neutral because nickel oxidation state is 0 and s orbital is filled. In this case, how can we create vacant s? Hybridization means starts with s orbital, right? sp3, sp2, sp3d2. But here s is filled. How can we create vacancy in the s orbital? This is strong field ligand. Then where pairing takes place? This electron will enter into this. Correct only, no? Yes. This is a different case. Keep one danger symbol for this. Danger. How pairing takes place? Look at this. Online students, this is a different example. Nickel tetracarbonyl. Pairing takes place but in a different way. Look at this. How? S orbitals are there. S orbital is there. Here 2 electrons are present. The 2 electrons entered into 3d cell. Then vacancy is created. Vacancy is created in s orbital. This is a different case. If you get lost class, then you can understand, right? After sending s electrons, the remaining structure. One, two, three. Right? And vacancy is created in s orbitals. We have few exceptional cases, don't worry. Right? This is 3D, this is 4s. One vacancy is created or not? One vacancy is created. But how many ligands are there? 4 guests. So we have to create 4 vacant rooms to accommodate them. Or we have 4 students. We have to give 4 empty rooms. Clear? How many rooms we have here? Only 1 room. Remaining? Remaining 3. But how can we get remaining 3? 4p. In the same floor, I said yesterday, one vacant flat, empty flat is there. So based on our requirement, we use that flat, right? So 4p orbitals also present in 4th energy level. So we use 3p orbitals. 1 s orbital and 3 p orbitals. sp3 hybridization. దీనివల్ల చూడు ఇప్పుడు మళ్ళీ ఇదంతా లైట్ వచ్చేసింది. వైష్ణవి టైం అంటే టైమే ఉండాలి, ఓకేనా? 15 minutes ఎంతసేపు నువ్వు లేట్ వచ్చింది? 4:30 అంటే ఎంత ఇప్పుడు టైం? sp3 hybridization. Okay. Sweta, paramagnetic or diamagnetic this is? Why diamagnetic? There is no single electron. There is no single electron or unpaired electron. Color or colorless? Colorless. You come for half band, I will, okay? First write geometry. Geometry, tetrahedral geometry. Tetrahedral. Magnetic property. Magnetic property. Online students. Did you answer? Is there any single electron here? Diamagnetic. Diamagnetic. Color, colorless. Colorless. Exceptional example. Nickel tetracarbon. This only will come. Only this. Yes. Direct question. Nickel tetracarbon. Okay. We have few exceptionals only. We can count 1, 2, 3 like that. Second exceptional case. For NEET level, rarely these type of questions will come. Like net tetracarbonyl. First two are normal models for NEET. Exceptional cases are rare, but for JEE means very important. This is also very important exceptional case. Right copper configuration, Aisha. Sweta, what is copper configuration? General copper. Argon 4s, 4s1 or 10? 4s1 3d 10 copper. Anomalous configuration or not? 4s1 3d10. Instead of 4s2 3d9, we write 4s1 3d10. Why? Because d10 is stable configuration. I taught already configurations. So first write copper, neutral copper configuration, argon 4s1 3d10. What is chromium configuration? What is chromium configuration, Sweta? హార్ట్ అటాక్ వస్తుంది. హార్ట్ అటాక్ వస్తుంది శ్వేత నువ్వు ఆన్సర్ చేస్తుంటే. అంతా నేను పట్టుకొని ఏమి ఎడిట్ చేసుకుంటా లేదు యూట్యూబ్లో, కానీ కాన్ఫిగరేషన్స్ నేర్చుకోపోతే ఎట్లమ్మా? క్రోమియం ఎక్సెప్షనల్ కదా. ఎంత చెప్పు, మన భక్తి చూడు ఎట్లా చెప్తుంది ఇప్పుడు. చెప్పు భక్తి. నువ్వు కూడా వెళ్తానే ఆయిషా యూ లెర్న్ నా యూట్యూబ్ క్రోమియం మీరు నేర్చేసుకున్నారు కదా ఇప్పుడు. క్రోమియం 4s1 3d5 exceptional case. Chromium and copper are exceptional. Okay. Yeah. Right, D and swapping. We have to remove 2 electrons, right? One from s orbital and one from d. 3d9 or 4s0. How to fill 9 electrons according to Hund's rule? First give on 1 electron, V1 one electron, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Online students, observe this example. Important, very important. A different concept we use here. So I given only 2 exceptional cases. Remember the concept of these 2 exceptional cases. Right. How many vacant rooms we required? What is the coordination number?
4.
How many vacant rooms we required? 4 vacant rooms we require. So more 3 orbitals I have to write. 4p0. 4p0, right? Correct only now? In copper, NH3 taken 4 times. Tetraamine copper plus 2. Okay, oxidation state is plus 2. No? In this complex, this is also very important exceptional case. One electron will jump from D to P. D to P. I'll tell the reason also. Okay, exceptional means exceptional only, and we have reason also. CuNH3 taken 4 is exceptional or not exceptional. What happens in that case? One electron jumps from D to P. So after jumping, next resultant configuration is, tell me resultant configuration. Online students, Surabhi, Obed, what happens, you tell me in this case? What is happening here? What I did now? Obed, what I did now, tell me. In Cu NH3 taken 4 times, what happens? One electron will jump from d orbital to p orbital, only one exception.
So, strong ligand because there is one d orbital, similar d orbital, so it's jumping to p orbital.
That is also one reason, but the main reason I'll tell you. First of all, write hybridization. What is hybridization here? Here one d orbital, s orbital, and how many p orbitals we take? 2 only. What is the coordination number? 4. So 1, 2, 3, 4. Don't take last one. 4. So read hybridization. ఇది కంటికి కనబడట్లేదా? DsP2. Hybridization is DsP2. Very, very, very important. DsP2 hybridization. For CuNH3 taken 4 times. For NEET students, this is optional. Optional means your interest. If you have good memory, then you can remember. Otherwise, go through first 2 examples, right? But my suggestion, only exceptional case only, no? So better to remember. Geometry. If hybridization is DsP2, then geometry is square planar according to chemical bonding. sp3 tetrahedral. DsP2 square planar. Geometry square planar. Square planar geometry. Okay. See the reason. Square planar. Square planar means that is a planar molecule. Planar molecule means all the atoms are present on the plane only. On the plane. Once look at this. Let us consider a molecule. In that molecule, 2 atoms are on the plane. Problem. 2 atoms are present on the plane. This is a planar. This is a planar molecule. This is one atom. This is one atom. 2 atoms are on the plane only. Planar. Planar. If any one of the atom comes out of the plane, that is non-planar. What about this? Why non-planar? This is One atom is on the plane, another one is above the plane, non-planar. See, when atoms comes out of the plane, they fight with each other in the space. Now there is no problem. All are on the plane only. There is no problem. There is no problem. When we get the problem, when atoms comes out of the plane, then only they repel with each other, fight in the space, becomes unstable. Square planar molecule is stable molecule. For example, instead of sending this electron into P, if you write sp3 means what is the geometry? Tetrahedral. Tetrahedral means non-planar. Non-planar means fighting will takes place between the orbital to orbital. Clear? Okay. So instead of all these things, what you have to remember, in CuNH3 taken 4, one electron will jump from D to P, and hybridization is dsp2, special case. Reason is, if we send D electron into P, we will get a dsp2 square planar geometry, that is a stable geometry. All orbitals present on the plane only, in the square planar. Planar atoms are stable than non-planar. That is the reason. So this is exceptional case. Right. We completed hybridization in tetra-coordinated. Let us take one example for hexa-coordinated with the coordination number 6. Same story, concept is same, everything is same. Okay. In tetra-coordinated, how many exceptionals we learnt? 2. Nickel tetracarbonyl and copper tetramine. Actual name is tetramine copper 2 ion. Okay, right. Next example, octahedral. Geometry of octahedral complexes. Octahedral complexes. See, in octahedral complexes, coordination number is 6. If coordination number is 6, then what are possible hybridizations and what are possible geometries? See, the complexes with coordination number shows 2 types of hybridizations, sp3d2 hybridization and d2sp3 hybridization. sp3d2 and d2sp3. Right, if hybridization is sp3d2, then geometry is equal to octahedral. Geometry is octahedral. Geometry is octahedral. This is very easy because irrespective of the hybridization, geometry is same for hexa-coordinated complexes. In hexa-coordinated complexes. Hexa. Octahedral annama manam 8 cases, but hexa-coordinated. Geometry octahedral. Right, let us take one example. Remember, when you get hybridization sp3d2 or d2sp3, what is the geometry? Very simple thing. If coordination number is 6, take geometry directly as very easy. 6, if you observe 6 ligands, or if coordination number is 6, geometry is octahedral geometry. One example, COCl6 minus 3. COCl6 minus 3. Online students, what is oxidation state of cobalt? What is cobalt oxidation state? Online students, what is cobalt oxidation state? శ్వేత కొద్దిగుంటే జరుంటే చచ్చిపోయింది అన్నట్టు అంతేనా? Here cobalt oxidation state, Aisha. Oxidation state. Yes, +3. plus 3. Atomic number of cobalt. Cobalt atomic number. 27. You tell you the atomic number? Tell the answer. Cobalt atomic number 27. Oxidation state. Oxidation state. Plus 3. Argon 4s2 3d7 because atomic number is 27. 4s2 3d7. Oxidation state is plus 3. How many electrons we have to remove? 3. 2 from s orbital and 1 from d orbital. So 4s0 3d6. 4s0 3d6. Next, swapping. 3d6 కేతురా ప్రాజ్ఞిక ఫాలో అవుతున్నారా మీరు? హలో, see 6 electrons were filled. Four is 0. How many vacant rooms we require? What is the coordination number? 6. We need 6 vacant rooms. But how many vacant rooms we have? 1. More how many? 5. First, second, third, fourth. In first orbit, which orbitals are present? 1 is 2s 2p, 3s 3p 3d, 4s 4p 4d and 4f. In fourth floor we have different flats, empty vacant flats, right? 4s is one flat, 4p is one flat, 4d is one flat, 4f is one flat. This is a building having 4 floors, right? Our relatives are coming, guests are coming. How many guests are coming? 6. 6 friends are coming, guests are relatives. 6. So we have to create how many rooms? For each person, one single room we have to provide. How many rooms we have here? Only 1. So remaining 5. In p orbital, how many suborbitals are there? Means in one flat again 3 bedrooms are there inside, like that. P is having 3 suborbitals, px, py, pz. So take p, 4p. But in this flat again 3 rooms are there inside. Next, 1, 2, 3, 4 only. Remaining. More how many we need? Here 1, 2, 3, 4 completed. More how many we require? 1, 2, 3, 4. 2 more required. Next, d orbital. Take d orbital. First give stars for this. Coordination number is 6. So 1 vacant room, 2nd vacant room, 3rd vacant room, 4th vacant room, 5th vacant room, 6th vacant room. This is 4D. 4D. We are taking 4D. Another flat also we are taking based on our requirement, right? Now join all this. How many orbitals we have to join? 1, 2, 3, 4, 5, 6. Say the hybridization. sp3 d2. sp3 d2 hybridization. sp3 d2. sp3 d2. Write other properties. What is geometry here? What is geometry? Geometry. If coordination number is 6, geometry is octahedral. Octahedral geometry. Magnetic property. Magnetic. Single electrons are present. If single electron is present or unpaired electron is present, then paramagnetic. Color property, color or colorless? Colored, because single electron is present. See, presence of single electron is a reason for the color property and the magnetic property. Magnetic moment value, spin only magnetic moment value, mu is equal to root over n into n plus 2 Bohr magnetons. What is n here? And n value. What is n here? Yesterday I explained this. 4. Number of unpaired electrons. Number of unpaired electrons. N is equal to 4. Value 4 into 4 plus 2. 4 plus 2 is 6. 6 into 4, 24. 24 value approximately 4.8. 25 is 5. We have to substitute n in this formula. Same, yesterday I given that mu is equal to root over 4 into 4 plus 2 Bohr magneton. 4 into 6, that is equal to 24. 24 approximately 4.8. 4.8 Bohr magnetons. That is spin only magnetic moment. Spin only magnetic moment value. Cl is strong field or weak field ligand? Cl is weak field ligand. Now, once look at this, all of you. 3D, 3D, 4s, 4p, 4d. ND, can I write n minus 1, ns. Once observe this, underline, online students. This is 4, its value 4 minus 1. 3 means 4 minus 1 only. N minus 1. Any confusion? N. This is n minus 1. 3D orbital means n minus 1. N minus 1. What about this one? Tell me. End. Any confusion in this? Take s orbital, 4s orbital. This is 4, this value is 3. 3 means n minus 1. This is 4, this is also 4. N only. Ns, Nd. Ns, n minus 1d. We have two different d orbitals. 3d orbitals are called as inner d orbitals. Inner d orbitals. Inner means you are not going out. Actually, when we go for vacant flats, when more guests are coming, right, we will go for higher floors, right? When we go for higher floors, for example, you are staying in the 4th floor. If rooms are not sufficient in the 4th floor, then what you will do? You will go to 5th floor or 6th floor, outer. If you use 4D orbitals, the complex is called as outer orbital complex. You are going for another energy level actually. When you use 4d orbital in any complex, that is called as outer orbital complex. When you use only 3d orbitals, that is called as inner orbital complex. In this case, which orbital you used? Which orbital you used? 4d used or not? Outer orbital complex. Very simple thing. In the hybridization, if you use 4d, that is called as outer orbital complex, there is no need of using 4d. You use only 3d, that is inner orbital complex. When we use only 3d, when internal pairing takes place, then we no need to go for 4d. Correct only now. For example, if here pairing takes place, then no need to use these 2d orbital, outer d orbitals. Clear? Now keep heading. Outer orbital complex. Outer orbital complex. Outer orbital complex. Very simple definition. The complex in which 4d orbitals are utilized in hybridization. The complex in which 4d orbitals within the bracket nd 4d orbitals within the bracket nd orbitals in which 4d orbitals are utilized in hybridization, then the complex is called as outer orbital complex. Sir, I didn't understand this inner orbital, outer orbital. Just you remember, during hybridization, if you get a 4d in your answer, if you used 4d, then that complex is called as outer orbital. Then the complex is called as outer orbital complex. Inner orbital complex. Next, inner orbital complex. Can you guess? Inner orbital means 3D. For example, you are staying in the 4th floor. Rooms present in the 3rd floor, 3D, because 3D I am writing. You are staying in the 3rd floor. Rooms are sufficient in the 3rd floor only. Some guests are coming. Sufficient rooms are there in the 3rd floor. You no need to go for higher floor, next floors. You are using rooms in your floor only. That is called inner orbital. For example, rooms are not sufficient. Then what you have to do? You have to go for next floor, 4th floor, outer orbital. Otherwise, simple thing, simple definition. When we use 3d orbitals in the hybridization, that complex is called as inner orbital complex. If you get any confusion with the explanation, remember this statement. If you use 4d, that is outer orbital complex. If you use 3d during hybridization, that is inner orbital. Very simple. 4p తోటి మనకేం సంబంధం? 4p తోటి ఎందులోనే రెండిట్లో 4p వచ్చేస్తుంది. రెండిట్లో 4p is the common in both, in inner orbital and outer orbital. Okay. శృతి, హలో. శృతి వచ్చావా? అదొకసారి 4th ఫ్లోర్కి వెళ్ళి మోక్షిత్ వస్తాడు, ఒకసారి చదివించుతాను. సరేనా? 4th ఫ్లోర్ కిందకి వెళ్దామా, టేబుల్ దగ్గర కూర్చొని బయట చదివించండి. ఓకే, బెల్ కొట్టి వస్తాడు, బయటకు వస్తాడు. If 3D orbitals are used in hybridization, then complex is called as inner orbital complex. And let us take one definition, then examples for it, we can understand easily. 3D orbital means n minus 1d orbital. 3D orbital or n minus 1d orbital, both are same. 3D orbital, another representation is n minus 1d. 4d is nd. 4d is nd. In the last case, you tell me which orbital we used. We went for 4d or not? So that is outer orbital. Let us take one example and you will get clarity. Okay, next example. Because this is important model question. Which of the following is inner orbital? Which of the following is outer orbital complex? One simple trick I'll tell you. When strong field ligand is present, mostly that is inner orbital. When weak field ligand is present, that is outer orbital. Note down the trick also. 90% cases we can apply this. When strong field ligand is present, you know which is strong field and which is weak field ligand. Then complex is mostly inner orbital complex. What is strong field ligand? Example, super memory. When weak field ligand is present, then which orbital? Then complex is mostly outer orbital complex. Then complex is mostly outer orbital complex. నిన్నటి క్లాస్ బాగా అర్థమైనట్టుంది మీకు కదా, కానీ స్టార్టింగ్ వాళ్ళు మిస్ అయినా ఒక 20 minutes క్లాస్. వైష్ణవ్ ఎందుకని లేట్ అయింది? రైట్. CO CN6 minus 3. CO CN6 minus 3. First of all, say atomic number of cobalt. 27. Oxidation state plus 3. Then write configuration draw 4s/3d7 and remove 3 electrons. Swap. Then arrange in the sequence, arrange the orbitals, and how many orbitals we have to, vacant orbitals we have to arrange. Right, see once all of you. Cobalt electronic configuration, argon 4s/3d7. Oxidation state is +3, so we have to remove 3 electrons. Argon 4s0 3d6. Swap and write. Five and 6. Here 4p, can I write 4p? 4p, can I write 4d also? First write, later we will decide whether we have to use or not. Sorry, 4d. Listen carefully. Cyanide is which field ligand? Strong field or weak field? Strong field ligand. So pairing takes place. See. This electron entered into this. This electron entered into this. Here you will get 2 new vacant orbitals. 2 new vacant orbitals. So after pairing, Right.
D2SP.
Correct answer. D2SP3. You tell me, what is the coordination number? 6. How many vacant rooms we need?
6.
1, 2, 3, 4, 5, 6. Is there any need to use 4D? No. If we do not use 4D, if we use only 3D, that complex is called inner orbital complex. Hybridization is C.
D2SP.
2 d orbitals, d2, 1 s orbital, s 3 p orbital, d2 sp3, d2 sp3. Okay. Right, remaining information. What about geometry? Octahedral. Magnetic property? Magnetic property. Diamagnetic. Color? Colorless. Colorless. Geometry, octahedral. Magnetic property, diamagnetic. Diamagnetic, there is no single electron. Color, colorless. Inner orbital or outer orbital? Inner orbital complex. Type of complex, inner orbital complex. When we use only 3D orbitals, that complex is called inner orbital complex. Inner orbital complex. Okay. Okay, we'll continue extension to this, right? PBT after CFT, crystal field theory. We have few more exceptional cases also. This is about PBT up to NEET level. If you have idea about all these things, that is enough. Finding magnetic moment, color property, hybridization. Mainly hybridization geometries are coming. Exceptional cases, nickel tetracarbonyl. Okay. Backup చేసేసేయండి వెళ్తా. ఇప్పుడు మీరు ప్రాక్టీస్ చేయాలి, రైట్? బై, సీ యూ ఆన్లైన్ స్టూడెంట్స్. ఒకసారి మీరు రేపు ఎగ్జామ్కి మళ్ళీ రాసేసుకుంటారు. సండే ఎగ్జామ్. సండే మీకు